Hello, everyone. Thank you for tuning into a live stream. This is the first one that I have hosted on my own without help from anyone else. So if you are logged on and watching right now, feel free to say hi in the chat. I have two goals for the stream today. I don't expect to be on too long, depending on how many people tune in. However, those two goals are the first one being just practicing streaming myself and figuring out how the microphone and the cameras and all of that works through the YouTube Live situation. And the second goal is just to answer some of the questions that I have gotten about the Tinybelt so far, ranging from specifics from the printer itself all the way up through some details about the Kickstarter campaign that I've been planning for what feels like forever by now, but really it's only been a few months. So I consolidated some of the most common questions that I have gotten into a notes document, and I plan to just kind of read off of those and answer questions. If you do have any questions, feel free to, again, put those in the chat, and I'm happy to answer them on the fly today. So let me get my notes pulled up. And if you're going to be distracted by around all over the place, this might not be the best live stream. Maybe listen audio only. But I'm going to be looking at my notes and the camera and all sorts of different things. So let's dive into it. And really, where I wanted to start was just talking about the goal for the campaign and really the goal for the project as a whole. And I've said it a few times, but for anyone that doesn't know, my main goal for this project is to create a printer that is or has the potential to become the Ender 3 of conveyor belt 3D printers. A lot of times in the 3D printing space, people, I think, tend to look down on the Ender 3. And a lot of that is valid because the Ender 3 is really a bare bones printer, right? They're not shelling out money for linear rails or an all metal hot end or a direct drive extruder. Um, there's no Wi-Fi connectivity. It's really stripped down to the basics of what a 3D printer can be made for inexpensively, but still have a high enough quality where it's able to be marketed to people and they can get up and running fairly quickly and start printing PLA with relatively little difficulty, you know? Um, and so as I look at the impact that the Ender 3 has made on the world of 3D printing, I can't help but be really impressed. See, the Ender 3 being open source has spawned tons of different clones. Uh, Different people that took the source CAD and made it their own. Maybe they copied it one for one and made one small adjustment. Um, but because it is so optimized for manufacturing and because it is minimalistic in nature, it has managed to have a tremendous impact on the world. You know, Prusa is incredibly popular and open source, and while I've only used one for maybe 30 minutes once, seems to make a great product. I would argue that the Ender 3 has had a much bigger impact on the world of 3D printing by being open source, by creating an ecosystem of low cost, um, easy to source components. Um, and so when I think about myself and what I want for the Tinybelt and what I want for PowerBelt 3D as a company, I want to be able to have as big of an impact as possible. I think about last year uh, during COVID when people were printing PPE all over the world, and everyone's 3D printers were stuck not working for hours and hours at a time, not being productive, not making parts for people. And that's because a lot of people who had inexpensive 3D printers were happy to chip in, But then they were also signing themselves up for a massive amount of babysitting, scraping parts off of plates. And when I thought about what that experience would have been like if all of those inexpensive printers were automated, that would have been tremendously different. I imagine we would have been able to make the same quantity of PPE with less people getting involved, less printers, less setting alarms for 2 in the morning to be able to change over jobs on different printers. Um, and that's really just the tip of the iceberg for me. Um, I used to work as technical support for a sales team that would sell industrial level 3D printers. We're talking hundreds of thousands of dollars. Um, and as a part of that role, I got to walk around, tour tons of different types of manufacturing facilities, places that made tires, places that made CNC machine parts, places that um, made food, just food packaging equipment, all sorts of different stuff. And what always stood out to me was that those processes at scale are tremendously automated. They're not always what you think of with a car assembly line with a bunch of robot arms working together. A lot of times it is just custom designed and built equipment. But those processes are almost always entirely automated. I remember I once went to a facility that manufactured hinges and latches for the automotive industry, for cabinets. Like, if there is a hinge or a latch on something, chances are they made it, or they made something that would work for that application. And die casting, which is kind of like injection molding, but with molten metal. So molten metal is pushed into a die and then ejected, and it would just crank out zinc parts, going from molten to solid state. Hey, Justin, thanks for tuning in. Um, they would just crank out these metal parts around the clock, 24/7. They would run 3 shifts so that someone was there. Hey there, Alberta. Thanks for tuning in. They would crank out these metal parts all around the clock, and it was all automated, right? It was impossible to be able to run an operation at that level without it being automated. If you can imagine a molding factory that required someone to go over to the mold and take the parts out of it every time one was done, the labor cost for that would make your products just exorbitant. When I was in this role too, a lot of people would talk to who are thinking about buying an industrial 3D printer would talk about, well, what's my uptime, what's my cycle time, like how many parts can I really get off of this, in an effort to um, figure out just how much of a financial impact it would make for their business. And usually a rule of thumb that I used was a 3D printer is only productive 80% of the time, right? It's a rule of thumb that the 20% of the time that a 3D printer could be working, it's heating up or cooling down or waiting for someone to come take the parts off of it. And usually they were very unhappy with that, right? Usually they were like, if we're going to invest $200,000 into a 3D printer, like, I want 99% uptime, because that's what they're used to with a lot of their industrial CNC equipment, right? Downtime is not acceptable. They book and schedule their jobs to be productive every hour of the day. And for some reason, that attitude hasn't really been adopted by the industrial 3D printing companies, at least not yet. I'm hopeful that maybe we'll get there at some point. Even if you look at production level equipment like large SLS equipment or binder jetting equipment, it's still not automated. It's still a batch process. And I'm hoping that by kind of starting with a minimalistic 3D printer that's fully automated and that is being able to print infinitely long objects, which is a nice add-on, in my opinion, we'll be able to figure out where it makes sense in the world of 3D printing, where it doesn't make sense. And because I hope this project will become open source, it will allow other people a starting point to be able to design better 3D printers that can serve some of those business needs. Um, and the other thing that I really like about the Ender 3 is that it's so many people's first 3D printer. My first 3D printer was an acrylic frame i3 kit that came in a box from China. Nothing was really labeled. The thing that was sorted, it was like a plastic bag full of tons of different screws, and I spent probably 3 or 4 days putting it together with um, very limited instructions, not the best explanations for things, but I had so much fun doing it, and troubleshooting and upgrading parts over time. And I managed to sell parts out of my apartment, and within 6 months, have the printer totally paid for. And that's just an experience that I want to help. Yes, my laptop is plugged in, Justin. I made sure I was super prepared. Last time we were on a call, for everyone else watching, my laptop died while Justin and I were talking, which is funny, but also kind of sad. But anyway, um, as I was saying, that printer experience where I was in college, I was able to split it with a buddy of mine and actually afford to have my own 3D printer was so, and it's an experience that I want other people to have and really scale up their businesses at an affordable level as it makes sense, right? So a lot of the other industrial 3D printers that I looked at or that I used to work with, um, a lot of times the starting point was $20,000 for a machine that really only ran ABS, a locked down system. Um, and I just think we can do better than that, right? I think over time, all of us have seen printers decrease in price but increase in capability since 2012. I think when Prusa and MakerBot and PrinterBot all first started. Um, so that's really my goal and my vision for this project is to make the Ender 3 of conveyor belt 3D printers something that is minimalistic and affordable and can get people started with fully automated printers. And figure out where angled slicing and infinite printing really fits in the 3D printing universe, if you will. So with that being said, I want to get into some more frequently asked questions that I've gotten from various people over the past few months, starting with some specifics about the printer. So the printer going to have roughly a build volume of 300 by 200 by infinity millimeters. And I'm planning to launch it on Kickstarter, which I know is controversial. But I feel like Kickstarter makes sense with me, right? I've been working on this project solo with some help from my wife and friends pitching in from time to time since I started prototyping in 2018. So I was working at my old full-time job until December of 2020. At that point, I decided that I really had to try to make something of this or I had to stop altogether. I didn't want to do that. So I've been doing this full-time and picking up some odd jobs throughout the year to help keep all my bills paid. But yeah, man, that was quite a sidetrack. The build volume, roughly 300 by 200 by infinity millimeters. And I made a note to look up the system footprint, but I failed to do that. So if anyone has a question on the system footprint, feel free to just shoot me a private message on Twitter is where I usually spend most of my time. Happy to answer any questions that come up. So I'm planning to launch on Kickstarter. I wanted to do it in November of this year, inspired by last year's super popular 3D print conveyor belt 3D printer Kickstarter. They ran their campaign from November kind of through January. So I was hoping to kind of match that timing. But ultimately, I was too optimistic for the timeline in how I could get printers to beta testers quickly. So at this point, right now on our Tinybelt page, I have it listed as starting in December. And while I think that I could launch the campaign in December, I feel like the best course of action is to wait till January, wait until all of the holiday craziness has kind of washed away, and start the new year off fresh. Um, right now, I'm planning on having a few different tiers for the Kickstarter. The first one, excuse me, being the maker edition of the Tinybelt. So I imagine this will be a sorted box of parts that I will send out to anyone that wants one. But you would have to 3D print your own parts, right? I've always wanted this project to be affordable and accessible for people. And printing your own parts does two things. One, it lowers the cost for myself. But more than that, I think it creates a little bit of a barrier to entry for people that, like, you kind of have to have your own 3D printer first to be able to have that reward tier make sense for you in the campaign. And the other thing I want to do is I want that tier to be Kickstarter exclusive, to really motivate people to support the launch of this. Because as I've been trying to run Power Belt for a few years now, I've never really hit the order volumes to create a profitable company, right? I've been ordering parts for 40 or 50 printers at a time. But to really hit an affordable price point of, $500, $700 of a retail price, I need to be ordering hundreds of printers worth of components at a time. So that's kind of my motivation, is to get a large enough set of orders all at one time, get the price down, and actually make a profitable organization. As Because that's what I think that we have to do to create the automated 3D printer revolution that I really want to create for everyone. So I would expect the campaign to start in January. I will have the maker edition of the Tinybelt kit under $400. Not making a whole bunch of money from that tier once all the costs are taken into account. But again, I want it to be affordable. It's a Kickstarter exclusive. And I want people to be able to get involved with conveyor belt printing. The top tier is still under $600, as the current spreadsheet says. So that one, I want to have 90% assembled to give people kind of like the Creality experience of being able to bolt on a couple different components and get up and running quickly. But also at the top tier, still under $600, I'm hoping to offer a couple upgrades, in particular to the hot end. I chose the Creality standard hot end, if you will, the Mark 10 style with a PTFE tube that goes all the way down to the nozzle, because they are inexpensive, because so many people have experience using them. They're easy to upgrade. But I've always been a fan of all metal hot ends, so I'd love to offer some sort of upgrade. I'm not totally sure what that will look like yet, but if you stay tuned and follow along with the campaign, I will obviously update you once things are more finalized. Slicing is always a big question that people have. If you go to the YouTube channel or our website, I have a couple articles on there just dedicated to how to orient your parts and also how to slice parts. The one article about slicing is a little outdated. I need to add a couple options to that article. Specifically, Kirimoto is a browser-based but still local slicer that I know offers belt slicing capability, but I've never played with it. But it should be added to the guide for completeness sake. I've been extremely happy with IdeaMaker, which is software from Raise 3D. It just has pretty much all the features that I would want in a slicer. Like, it has modifier meshes, it has custom support capabilities, It offers belt printing. What's really cool is that I can have my belt printers and my non-belt printers all in one piece of software, which when I was using Black Belt Cura, I usually had to switch from that to Repetier Host or to Slicer or to Cura, normal Cura, in order to have all of my belt and non-belt printers in one program. So that's what I've been recommending for people. I've been building print profiles and machine profiles for Idea Maker and making those available to all of the beta testers so far. And I 100% plan to do the same for the actual launch of the Tinybelt. A couple other more campaign specific questions is do you have the manpower to assemble a large number of printers? And as I started thinking about this more, the honest answer is today, no. I've been working, like I said, by myself with friends and family pitching in from time to time. However, we do have a couple things I think going for me. 2 months ago, I started renting a very small office that I found on Craigslist, so that I have a place outside of just the spare bedroom, which my wife really wanted to be cleaned out. And so I have an actual workspace now that can be dedicated just to Power Belt. And it's small, it's about 600 square feet, 500, 600, but it's attached to another larger area that is split both office and warehouse that I can expand into. It's in the same building pretty easily. And I think just location outside of where I live will help to be able to hire people so that they have a place to go to work that's not my house. That would be strange. Right where my office is located is about 4 minutes from the Dayton STEM School. So this is a STEM dedicated high school. I know they have some technical internship requirements, so I'm hoping that can be potentially a good source of technical abilities, but also 4 minutes away from my office where I can get some affordable labor to help actually assemble printers. The office is also located less than 10 minutes from a community college and the University of Dayton. So again, I'm thinking young, affordable talent that they can learn about 3D printing, get hands-on experience, assembling printers, which you can just learn so much from if you've ever built a printer from an actual kit. I see Alan from Repcord has joined us. Hey, Alan, thanks for tuning in. So we have all of that going for us in terms of some labor availability and a location for people to go to build printers. But that being said, during the year of 2020, I was working full time. And even by myself, I shipped about 50 printers all over the world. So it did take like a whole year to go through all of those printers, but I think it says something about what I can accomplish working solo with some help from friends and family. I'm at this point setting the Kickstarter goal at around 100 machines. So I would for sure need help in order to move quickly in that fulfillment. But even doing it myself, with it given enough time, I could make it happen. Most of those 50-ish printers that I shipped throughout 2020 were not assembled. They were just like a well-organized box of parts. But still, were fully assembled and shipped that way. Yeah, shipping 50 printers while working full-time. I had to travel for my job too, so well, not so much in 2020. So I take that back. Regardless, it's something that I think I can be pretty proud of, and is a testament to what I can get done without needing to hire extra hands. I haven't tried Kirimoto yet. I mentioned I've just been too happy with Idea Maker that I don't want to give it up. It makes modifier meshes super easy, which I tried using Prusa Slicer for that sort of thing and more advanced slicing options. And the interface just was a little difficult for me to get a hold of. But I've been super happy with Idea Maker. It is on my list of things to do to try out Kurimoto because I know some other people are happy with it. I've heard that they do multi-material tool changing dual extrusion, which is really interesting. So it's on my list of things to do. It wouldn't be too difficult to translate the Idea Maker profiles over to Kurimoto for people that want to use it once the launch is actually behind us. I also got a question around how long will it take to ship once the campaign ends. And based on all of my experience over the past few years, bringing in parts from China, sorting them, it's really hard to do anything in less than 90 days. And that's under normal conditions without the global supply chain challenges that we're experiencing at this point. I can be confident, I think, in starting to ship printers 90 days after the Kickstarter funds came in by using air freight instead of sea freight. So shipping things on planes instead of boats, way more expensive. We're talking 3 times, if not a little more expensive. But you gain the advantage of not having stuff sitting on a boat in LA or New York instead of at your facility where you need them. So I imagine that depending on how big the campaign ends up being, I could do a small order for 30, 40 machines air freighted into the US. And then for, call it number 31 through 200, that could be on sea freight and then show up later. And hopefully by the time I actually get the first 30 printers out the door, the second shipment will be coming in, everything will move nice and smoothly. I already talked about the target for the number of printers. It's 100. I think 100 printers is a number that I'm happy with because it proves that this is something that people want, right? That's a big, I think, appeal of Kickstarter that not a lot of people talk about, is its use as a market testing tool, where you can kind of put up an idea, and if people want it, they can support your project. So at 100 printers, that's a big enough volume that I think it proves that people would want the Tinybelt, but it's not too big of a number where maybe the funding goal is too far out of reach. Other specs, at this point, I'm dedicated to silent stepper drivers. I realize that kind of pushes it outside of the goal of being the Ender 3, because we could go with cheaper stepper drivers. But having used them, it is just so beautiful to have, multiple machines running, and really all you hear are some cooling fans for the power supply, for example. It's so much better than I have an Ender 3 over to my left than those loud stepper drivers. So we're going to be using silent stepper drivers. We're going to use a 32-bit control board. I consider those really just like modern luxuries or necessities for printers to have, having had some experience with them. It's going to have a Bowden dual gear extruder, which is identical to the one, or nearly identical to the one. I don't want to say fully identical to the one on the Creality CR30. Having used and testing it on a few different machines, I'm really happy with it so far. It'll have a heated bed. Again, I think that's one of the things that modern 3D printers need. If you guys have any other questions, feel free to put them in the chat, and I'm happy to answer them because we're getting to the end of my my notes sheet. But I did achieve my goal of going over frequently asked questions and practicing live streaming. So it might be a short, sweet live stream, which I think is okay. Looking at some of the chat, belt layer specific parameters, beefing up extrusion, that would be a really nice feature. So in the chat, Ripcord is talking about a really specific aspect of belt printing that a lot of people don't talk about. So in angled conveyor belt 3D printing, Um, every layer is sort of your first layer, okay? And that's because your outer shell, your outer perimeter, always has to make contact with the belt. And so the downside of this is that when I'm running printers, I'm usually running the outside contour pretty slow, like almost as slow as you would with just a first layer. We're talking 15, 20 millimeters per second. Obviously increases your overall print time. Um, but Repcore is mentioning that they're looking at some belt layer specifics. So ideally, in my opinion, you could move quickly for your outer shell on 3/4 of your print, the sides that aren't touching the belt, but then slow down for just the part of your outer shell that is touching the belt. Um, right now, we don't have any printers for sale. I want to stay laser focused on the beta testing process. So, how all of that kind of developed was initially we had an application for beta testers. I was very excited, but also a little overwhelmed by the big response I got. I got over 170 applications in like 24 hours. So I opened and closed the application pretty quickly. The vast majority of beta testers are paid beta testers. So they contributed a few $100s to help cover the expense of just really giving this project its first steps, which I appreciate so much. I've poured thousands of dollars into just getting the beta units here and getting the initial testing done, but it would not be possible without them. There were a small number of unpaid beta testers chosen. Typically, those were early supporters of the Zero. So I thought, based on their experience already building a belt printer that I had designed, they would be great beta testers for this next generation. All that being said, right now, there is a very small amount of beta printers that aren't going directly to beta testers. So some of those I will be keeping so that I actually have enough capacity to print the parts for the Tinybelts at their actual launch. And then there's another small amount of those that I'm hoping I can send out to some higher end, very popular creators if I can get them to commit to that sort of thing. Um, looking at marketing for a second, which is something that I'm an engineer but have learned so much about from books and podcasts over the last couple of years. I think as much as I like the word or the term influencer, they do just a fantastic job at getting the word out about new projects and new products. If you can talk them into featuring something that you're working on. So I'm hopeful that that will pan out. But again, that's looking at after the holidays at this point, when everyone is crazy busy. Other questions, options for Clipper, options for a Chimera. I'm not familiar with the extruder that iFactory is using necessarily. You can do, in theory, like technically speaking, you could do a direct drive extruder. You can do any upgrade to the extruder that you would want from a remote Bowden type setup. However, you want to keep in mind that the y-axis is a cantilever arm. So you're going to want to keep it as light as you can so that there isn't any deflection, because that will change the print angle very slightly, which is going to damage your accuracy, your surface finish, all that sort of thing. I think I do want to try out an orbiter direct drive extruder on one of these at some point, because they are super light, and because our X carriage is 3 millimeters steel and it's incredibly stiff, it's heavy. You can really tighten the V wheels against the rear aluminum extrusion, and I'm referencing off to my right because I have a Tinybelt printing over to my right, so I'm looking at it and referencing it. Clipper is totally a possibility. I know a couple of the beta testers were super excited to try to get Clipper installed. I don't see myself shipping with Clipper out of the box at any point in the near future. Again, I think some of those upgrades, like a Chimera or a Clipper or a Micro Swiss hot end, um, it's not in focus with the goal of becoming the Ender 3 of conveyor belt 3D printers. I think some of the beauty of the Ender 3 is that it gets your foot in the door, and then it's inexpensive enough that people are comfortable spending an extra $50 on an orbiter extruder, or another smaller amount of money on Raspberry Pi or something like that. But without an accessible price point to get people in the door, they never even have kind of that opportunity, if you will. Looks like Justin is running Clipper on his. No surprise there, based on kind of your background in the Voron communities. Very cool. A couple of people being fans of the orbiter. That's good to hear. I love that feedback. I held one in person. I see pictures of different printer components online all the time, and usually I'm a hard person to convince of like, oh, I should go spend $50 on an extruder upgrade. But I went to Rapid this year and I held one in my hand at the printed solid booth, and I was like immediately blown away at how light it was and how small it was compared to like a direct drive NEMA 17. It's an order of magnitude lighter. So it's something that I'm pretty excited to try out at some point. If you guys have any more questions, again, put them up in the chat, and I'm happy to answer them. Otherwise, I'll look to start wrapping up. As I mentioned, I haven't tweeted or Instagrammed or anything about it yet. But a big part of my goal was just to practice live streaming this evening, because tomorrow I'm going to be doing a much longer stream from the comfort of my kitchen table, so that I can plug the Ethernet directly into my laptop, based on where our router is located and all that. I'm going to be doing a live stream of a full Tinybelt build. So I assembled a kit just for myself that is a box of parts. And in a few hours, I'm hoping to take that box of parts and transform it into a functional Tinybelt, at least insofar as not doing all of the fine-tuning calibration process, because that involves just running prints, measuring things, and that wouldn't be fun to watch. But tomorrow, starting at 10 a.m. Eastern Standard Time, I'm going to be building a Tinybelt. Very excited. I've never done a live stream that elaborate before, so I'm going to try my best. It might be a chaotic mess, but hopefully it'll be an interesting chaotic mess to watch. So if you're free tomorrow, I'd say between 10 a.m. Eastern Time and probably 3 p.m. Eastern Time. That's usually how long it takes me to go from a box of parts to a functional printer. Then it would be awesome if you want to pop in, say hi, again, ask questions, anything like that. Danny, it will do PETG. Nowadays, I'm pretty much exclusively running PETG. I have a couple rolls of like silk PLA or wood fill PLA for when I want to do something special or aesthetic. But other than that, I'm pretty much exclusively printing PETG for all of my functional stuff. All of the printed parts on the Tinybelts are PETG. So the answer is yes, it'll do PETG. We ran into some challenges with the heat beds for the betas, some communication challenges with our supplier. So at this point in time, they struggled to reach higher temperatures for something like nylon or ABS. But when I was running the zeros with the exact same Formula 32 conveyor belt, I did manage to print ABS and nylon without any challenges. honestly, with surprisingly few challenges for an open printer um, with ABS. So it's totally possible. Um, Obviously, you may have to adjust some settings in your slicer, but certainly possible. Okay, everyone, thank you so much for taking the time to tune in. Progress on beefing up the seam on the belt. I am trying to create a seamless belt. I did buy an impact sealer a couple months ago and tried to thermally seal the seam on our Formula 32 conveyor belts. It did not work as well as I had hoped. The off the shelf impact sealers just don't get hot enough to, I think, really melt and fuse it the way that I want it to. Um, I did work on some process changes before I shipped any tiny belts to try to create a truly seamless belt, which I can't go into all the details of. Um, it wouldn't be interesting, but it's a work in progress. Um, I have plenty of ideas. Um, Really, I think it's about the manufacturing process that's going to take us from uh, where we're at today with a belt that needs to be joined with a seam. I'm hoping to get that kind of sorted out in between now and the launch of in the Kickstarter launch. Um, but it's challenging. I did make two. I successfully made two closed loop belts, but then they were damaged very quickly as a result of the manufacturing process, if you will. It's so weird to call me making something a manufacturing process, but other things related to belt technology that are in the works are have a half baked bot that I've been so focused on the tiny belts that I haven't poured effort into it that will precisely meter out some of the components. So it'll be very consistent, whereas right now it's just spread thinly by hand. So that will hopefully lead to a higher quality product. Another thing that is in the works for belt technology is a CNC drag knife to precisely cut things. Right now, I have invested in a fun little collection of straight edges, both just large yardsticks and carpenter squares, whatever the ones that are completely flat. I have quite a collection of those at this point that I use to measure as best as I can by hand. But that's not particularly scalable when you talk about doing hundreds or thousands of printers. It's also not the most precise thing in the world, which is why I have some of those bots that are half baked at this point to take on some of those tasks from me. Um, Happy to hear that you had some luck with the belts that I sent you. Um, and yeah, the seam is a challenge. I think that it has some merit to it on its own when you're trying to swap out conveyor belts because you don't have to remove the heat bed. You can just kind of trim it. That also helps with bed or belt leveling. Um, so I imagine maybe at some point in the future we'll have the quick change seamed conveyor belts, and then we'll have the closed loop conveyor belts. Another thing that is half baked is trying to figure out a way to add texture to the conveyor belts. So there's some stuff in my Amazon cart that I haven't pulled the trigger on yet, but that should make that possible, which will only help with part adhesion. But that's something that's down the line for sure. Um, so having rambled a lot about stuff that I hope to do over the next 6 months, 3 to 4 months, you can tell that I have a whole bunch of stuff going on, and I'm very excited about the project um, and what we can accomplish together. So with that, I will open the floor for last chance for any questions, and then I have to figure out what my wife and I are going to do for dinner. Alan, I know you're busy. I have no hard feelings whatsoever about sending the belt back to me. Um, but I would totally trim it down and put it on one of the tiny belts. Okay, again, thank you everyone for tuning in. If you are free sometime tomorrow between 10 a.m. and 3 p.m. Eastern Standard Time, feel free to come back to the YouTube channel where I'll be putting together a tiny belt. And like I said, hopefully having a lot of fun or having a fun mess to watch. Like I said, you can always get a hold of me on Twitter. Is where I like to hang out the most. Or we have a contact form on our website. I don't check email every day because we just don't get enough email for that to really matter. But anyway, thank you all for watching. I hope you enjoy the rest of your night and happy birthday.